Okay, let's go to our third application. Our third application is about those counter application when the input signal bounces excessively. So we do have some fake transition due to bounces of the signal. So it's about fake transitions. Okay, so let's see what does it mean to have fake transition. I want to show you an example here. Let's assume that we are having an application in which we are counting the number of bottles on a conveyor. So what we expect to see is a signal like this. So in this signal, what you can see here is that, let me use a highlighter here. So in this signal, what you can see here is that while the bottle is in front of your sensor, the sensor will provide 1, and while there's no bottle in front of the sensor, it will be 0. So this is the ideal signal that we would like to get from the output of our sensor. But sometimes, due to the operating margin of your sensor or some noises or some problem in the environment, some vibration, we might see some signal like this. So at the beginning and at the end, when the bottle is passing in front of the sensor, we might see some rapid transition from 0 to 1 and back to 0, and that's because of the fact that the sensor is not confident if the object is in front of it or if it's not. So at the beginning and at the end of sensing process, it might not be an accurate signal, and because of that, the value of the output bit might fluctuate between 0 and 1 rapidly until it gets stable. But the problem is that if we fed a signal like this into our counter, what will happen is that the counter will count every single transition from 0 to 1. So 0 to 1, 0 to 1, again 0 to 1. So all those transitions will be counted. Even though we have only one bottle in front of our sensor, the sensor will count 3 times because of those fake transitions. So in this scenario, we want to make sure that these transitions are sealed. And we have to make sure that the instability of the input signal does not cause an unstable counter. So changes should be masked by sealing instruction. Now, how does it work? What we know is that it's not practical to have 2 bottles so quickly. So using the fact that we cannot have 2 objects right after each other because the length of our bottle is 1 inch, and then there is a distance to the other bottle which is 2 inch. So it takes time to get to the second bottle. Let's assume this time is, for example, 3 seconds. So in order to see the second bottle, we need at least 2 or 3 seconds. So this way we can seal our signal by a timer. So what we can do is that using the first transition, we can consider the first transition and use this first transition to enable a timer for a length equal to 0.5 seconds. So as soon as the timer receives the first transition from the sensor, it will be enabled. And then we can use the bits of our timer, which is within the software and it doesn't have any transition because there is no physical component involved. So we can use the bits of timer as trigger for the counter. Let's see how it works. So this is the program that we basically need to have.